Okay, you can see here 16, 1, 9. 16 means the number of carbon, 1 is the double bond, and 9 is the position of double bond. 16 minus 9 give us 7, and it's omega 7 family. Here 18, 1, 9. 18 number of carbon, 1 is number of double bond, and 9 is the position of double bond. 18 minus 9 give us the omega 9 is oleic acid. And here 18, 2, 9 and 12. 18 is the number of carbon, 2 is the number of double bond, 9 and 12 is the position of double bond. And 18 minus 12 is 6, and it's belong to the omega 6 family, linoleic. Here 18, 3, 6, 9 and 12. 18 number of carbon, 3 is number of double bond, 6, 9 and 12 is number of is position of the double bond, and 18 minus 12 give us omega 6 family. And 18, 3, 9, 12 and 15, 18 minus 15 give us omega 3 is linolenic acid. These two types, linolenic and linoleic, are essential fatty acid for our body, and related to arachidonic acid because it have a 20 carbon and 4 double bond on carbon number 5, 8, 11 and 14. 20 minus 14 give us 6, and it's belong to the omega 6 family. And finally, the omega 3 other family of omega 3 is eicosapentaenoic acid and docosahexaenoic acid, which are in fish oil. And for this reason, fish oil is so useful in our body because it's enriched in omega 3 oil. Okay, and also again you can see the common name and the structure of lipids. And butyric acid have a 4 carbon, carpic 10, palmitic 16, palmitoleic 16 with 1 double bond, stearic 18 without double bond, oleic 18 1 double bond, linoleic 18 with 2 double bond, alpha linolenic 18 with 3 double bond, arachidonic 20 with 4 double bond, lingosteric and neronic steric 24 with 1 and no double bond. Okay, as I mentioned in last slide, we have a essential and non-essential fatty acid. Essential fatty acid uh, cannot produce in our body, and we need to provide them by food and from dietary which we use. Based on dietary point of view, saturated fatty acids are synthesized by human body and no need to provide as external source. Not no essential as unsaturated fatty acid. So they are called non-essential fatty acid. Essential, they are unsaturated fatty acid which must be taken by human because this type of fatty acid cannot be synthesized in the body. So they are very essential, called essential fatty acid. Okay, after knowing the structure and nomenclature system of fatty acid, and also about the essential and non-essential fatty acid. You must know about the isomerism of fatty acid. The carbon chain of saturated fatty acid form a zigzag pattern when extended at low temperature. At high temperature, some bond rotated causing chain shortening, which explain why biomembrane become thinner and increase in temperature. A type of geometric isomerism occur in unsaturated fatty acid. Just in unsaturated fatty acid, we have a geometric isomerism. Depending on the orientation of atoms or groups around the axis of double bond. If the acyl chain are on the same side of the bond, it ceases, as you can see here, as in oleic acid. If they are on opposite sides, it is a trans. Is in a allydic acid, the trans isomer of oleic acid. Trans fatty acids are present in certain food rising as byproduct of saturation of fatty acid during hydrogenation or hydrogening of natural oil in the manufacture of margarine. Related to physical and physiologic property of fatty acid, which reflect chain length and degree of unsaturated. As I mentioned in the table, the melting point of even-numbered carbon fatty acid increase with chain length and decrease according to the unsaturation. A triacylglycerol containing 3 saturated fatty acid of 12 or more carbon is a solid at body temperature. Whereas if the fatty acid residue are polyunsaturated, it is liquid to below 0 centigrade. In practice, natural acylglycerol contain a mixture of fatty acid to suit their functional roles. For example, membrane lipid, which must be fluid at all environmental temperature, are more unsaturated than storage lipids. Lipids in tissue that are subjected to cooling, for example, during hibernation or in the extremities of animal, are also more unsaturated. Omega-3 fatty acids have a different function and are useful in our body. They can act as an anti-inflammatory and they have a health benefits. Long-chain omega fatty acid like alpha-linolenic or ALA found in plant oil, eicosapentaenoic pentanoic acid EPA found in fish oil, and docosahexaenoic acid DHA found in fish oil and algal oil are so useful for our body. Current evidence suggests that diets rich in omega fatty acids are beneficial, particularly for cardiovascular disease, but also for other chronic degenerative diseases such as cancer, rheumatoid arthritis, and Alzheimer's disease. Okay, fatty acid is finished. And here we are going to talk about the triacylglycerol structure and function. Triacylglycerol are the main storage form of fatty acid. And they are esters of trihydric alcohol, glycerol, and fatty acid. As you can see here, it is the structure of glycerol. three carbon, carbon number 1, 2, and 3, and trihydroxyl group, which this trihydroxyl group bond to trifatty acid number 1, 2, and 3. Mono and diacylglycerol, wherein one or two fatty acids are esterified with glycerol, are also found in tissue. These are of particular significance in synthesis and hydrolysis of triacylglycerol. Carbon number 1 and carbon number 3 are not identical. Okay, after you be familiar with the structure of triglycerol or triacylglycerol, what is the function of triglyceride or triacylglycerol? Long-term energy storage as well as insulation and protection are the main function of triglyceride. Triglyceride also provide our body with energy, but their main function is to storage energy for later use. The food which we use contain calories in the form of carbohydrate, protein, and fat. When we consume more calorie than our body its need, it store in form of triglyceride. Fat cell should be a triglyceride molecule until our body needs energy, such as between meals. Hormone signal lead to release of triglyceride from fat cell or adipose cell to our body for using. After recognizing fatty acid and triacylglycerol, now we want to get acquainted with another large and important group of lipids which are called phospholipids. Phospholipids are the main lipid constituent of membrane. Many phospholipids are derivatives of phosphatidic acid, in which the phosphate is esterified with one OH group of glycerol, and the other two OH group are esterified with two long-chain fatty acid. Phosphatidic acid is important as an intermediate in the synthesis of triacylglycerol as well as phosphoglycerols, but is not found in any great quantity in tissue. Sphingolipids such as sphingomyelin, in which the phosphate is esterified to the sphingosine, is a complex amino alcohol with a fatty acid. Both glycerophospholipid and sphingolipid have a two long-chain hydrocarbon tail, which are important for their functional in forming the lipid bilayer. As you can see here, the phosphatidic acid composed from glycerol plus two long-chain fatty acid, which fatty acid in position number 2 is unsaturated with a double bond and a phosphor group. This compound is called phosphatidic acid, which is the basis and the father of all of phospholipids except for sphingomyelin. Okay, phosphatidic acid is composed from glycerol, 1 and 2 fatty acid, and phospho group. Here, instead of this oxygen group, we can have a lot of compound and they produce different type of phospholipids. And the O in phosphatidic acid is substituted by a different compound you can see here. The phosphatidyl ethynylamine, which instead of H we have a CH2 NH3, and phosphatidylcholine we have this compound which is called choline, and phosphatidylserine which have a amino acid serine, and phosphatidylglycerol instead of O have a glycerol, and phosphatidylinositol have a this alcohol which is similar to sugar, and cardiolipin have a phosphatidylglycerol extra in its structure. Phosphatidylcholine or lecithin and sphingomyelin are abundant in cell membrane. Phosphatidylcholine, commonly called lecithin, is the most abundant phospholipid of the cell membrane and represent a large proportion of the body store of choline. Choline is the important in the nervous transmission as the form of acetylcholine and as a store of methyl group. Dipalmitoyl lecithin, as you can see here, is a very effective surface active agent and major constituent of the surfactant, preventing the adherence due to the surface tension of the inner surface of the lung. Its absence from the lungs of premature infants causes respiratory distress syndrome. And most phospholipids have a saturated acid in carbon position number 1 and unsaturated fatty acid in carbon position number 2. Phosphatidylethynylamine or cephalin and phosphatidylserine found in most tissue are also found in cell membrane and differ from phosphatidylcholine only in that ethynylamine or serine respectively replaces choline. Phosphatidylserine also play an important role in apoptosis or programmed cell death. And sphingomyelin are found in outer leaflet of the cell membrane lipid bilayer and are particularly abundant in specialis area of the plasma membrane known as a lipid raft. Phosphatidylinositol is a precursor of second messenger. Phosphatidylinositol is a minor component of cell membrane but play an important role in cell signaling and membrane trafficking. Phosphatidylinositol may have 1, 2, or 3 phosphate group attached to the inositol ring. Phosphatidylinositol 4,5-bis-phosphate or PIP2, for example, is cleaved into diacylglycerol and inositol 3-phosphate upon stimulation by a suitable hormone agonist, and this both I mean diacylglycerol and IP3 act as an internal signal or second messenger for some type of hormone, which you will learn them at the in the hormone session. Here you can see the cleavage of phosphatidyl inositol through inositol 1,4,5 phosphate or IP3 in brief and diacylglycerol. Uh, the phospholipids C in plasma membrane, which is sensitive to some type of hormone, act this action. And after that, IP3 lead to release of intracellular calcium and regulation of other enzyme by calcium. Also, diacylglycerol activate the protein kinase C, which this protein also can be activated by calcium. And finally, diacylglycerol and this calcium regulate other enzymes by protein phosphorylation, which you can see this type of phosphorylation in some enzyme such as a glycogen phosphorylase. Other type of phospholipid are cardiolipin. Phosphatidic acid is a precursor of phosphatidylglycerol, which in turn uh, produce cardiolipin. Uh, Phospholipid is found only in cardiolipin is a type of phospholipid which is found only in mitochondria and is essential for mitochondria function. Decreases cardiolipin level or alteration in its structure or metabolism causes mitochondrial dysfunction in aging and in pathologic conditions including heart failure and hypothyroidism and Bart's syndrome, which is called cardioskeletal myopathy. Okay, cardiolipin so is so important for function of mitochondria. Other type of phospholipid are lysophospholipid, which is produced in metabolism of phosphoglycerols. These type of phospholipid are phosphoglycerol containing only one acyl residue. For example, lysophosphatidylcholine or lysolecithin, as you can see here, which have one fatty acid here and the phosphocholine on carbon number 3, but in carbon number 2 we don't have fatty acid. It is called lysophosphocholine or lysolecithin. Plasmalogen occur in brain and muscle. This compound constitute as much as 10 to 30% of phospholipid of brain and heart. Structurally, the plasmalogen resemble phosphatidyl ethynylamine, but they have an ethyl link on carbon number 1 instead of the ester link found in acylglycerol. As you can see here, the ether bond there is in plasmalogen. Typically, the alkyl radical is in an unsaturated alcohol. In some instance, choline, serine, or inositol may be substituted for ethynylamine. The function of plasmalogen remains poorly understood, but It has been suggested that they may have a protective effect against reactive oxygen species. Here we have a two type of plasmalogen and platelet activating factor, which they have a ethyl link in carbon number 1, and platelet activator factor or PAF also instead of this fatty acid have a acetyl ester here. Glycolipids or glycosphingolipids are important in nervous tissue. The sphingosine containing lipids may be of three types: phosphosphingoside, glycosphingolipids, and sulfated. All sphingolipids have the long aliphatic amino alcohol or sphingosine, which is attached to a fatty acid in amide linkage to form a ceramide. The fatty acid has a chain length varying from 18 to 24 carbon. Phospho sphingoside also they contain a phosphoric acid group. A common phosphosphingoside present abundantly in biomembrane, especially of the nervous system, is sphingomyelin. It contains choline, and sphingomyelin are the only sphingolipid which contain phosphate and have no sugar. They are found in large quantity in nervous system. Different sphingomyelin may be formed depending on the fatty acid attached. Common fatty acid found are lingoseric and nervonic and also cervonic acid. Because of its amphipathic nature of sphingomyelin can act as a detergent, and the relative proportion of lecithin and sphingomyelin is important in biological fluid like bile, amniotic fluid, and etc. Sphingomyelin combined with fatty acid is called ceramide, which is a component of glycosphingolipids.